In today's class, we are going to see the Cannizaro reaction and its mechanism. Actually, what's the condition for a compound to undergo this Cannizaro reaction? This is the condition: aldehydes without alpha hydrogen atom can undergo this reaction. All the aldehydes without alpha hydrogen can undergo this reaction. For example, benzaldehyde, it's an aromatic aldehyde having this formula C6H5CHO. Its structure is given as follows. We know the benzene structure in which the hydrogen is replaced by the functional group CHO. You will just see the carbon bonded with the functional group. This is the carbon attached with the functional group, is called alpha carbon, and this carbon is not containing any hydrogen. So you can say benzaldehyde is not having any alpha hydrogen and it can readily undergo this reaction called Cannizaro reaction. And formaldehyde is another example, aliphatic aldehyde, that is also undergo this one Cannizaro reaction as there is no alpha hydrogen atom. You see a derived aldehyde called salicylaldehyde in which there is no alpha hydrogen atom, and hence this can also undergo Cannizaro reaction. So we can take this as an example, benzaldehyde, and how that is undergoing this reaction. The Cannizaro reaction is also called as, there are some other names for the reaction. This is also called as disproportionation reaction. And also called as self-oxidation and reduction reaction. Because one molecule of benzaldehyde will undergo oxidation and other one will undergo reduction. For example, we can take C6H5CHO, benzaldehyde molecule 1 and the benzaldehyde molecule 2. They are reacting with each other in presence of NaOH. The oxidized product of benzaldehyde is benzoic acid, and we are obtaining its sodium salt as a product, C6H5COONa. And the reduced product of benzaldehyde is benzyl alcohol, C6H5CH2OH. So this is nothing but sodium benzoate, and this is the compound called benzyl alcohol. And we should explain how these two products are formed starting from the benzaldehyde with the help of reaction mechanism. So we will try to discuss about the reaction mechanism behind in this Cannizaro reaction. There are three simple steps involved in that. We will try to discuss all the three simple steps. Step number 1. Take a molecule of benzaldehyde. Yes, this is the formula for benzaldehyde. C6H5C double bond OH. It is to be treated with the base like sodium hydroxide, NaOH. In the stage 1, OH minus, which is behaving like a nucleophile, and it is attacking this particular carbon. While the attack of carbon, there will be initiation of bond between the carbon and OH. Subsequently, the oxygen is removed, or the bond is removed between the carbon and oxygen can carry minus. So this is the intermediate we can have, C6H5, it becomes CO minus. We have substituted this OH, already the carbon is having the hydrogen. So that's the stage 1. I repeat, while the attack of nucleophile, a new bond is formed in between these two. Due to that, the existing bond is broken, thus oxygen is carrying minus. So that is stage 1. Step number 2, take the product as your reactant, C6H5 CH, O minus and OH, and take the first molecule of benzaldehyde, C6H5, C double bond OH, the stage 2. We can extend an arrow like this. The arrow denotes that this hydrogen is shifted to the carbon. Usually hydrogen is removed as H plus, but here the hydrogen is shifted in the form of H minus with the electron. It is moving and it is making a new bond with the carbon atom. Try to follow the arrow mark. While the attack, the existing bond is broken and oxygen can carry minus. And always the valency of carbon atom is equal to 4. To have the valency 4, there is a need of one more bond. How that is compensated? The electron pair lying on the oxygen is moving towards this side. So there will be new bond in between the carbon and oxygen. So these are all parallelly happening. I repeat, the hydrogen is given to the carbon with the electron pair and it is making a bond. Subsequently, this bond is getting broken. Oxygen can carry minus. Similarly, the oxygen containing the electron pair. This pair of electron is moving towards the carbon and oxygen, that is initiating a new bond in between these two, carbon and oxygen. Execute all these changes and find your product C6H5, C double bond O, this is OH, plus in addition to that C6H5, CHH, and this is becoming O minus. It is a product made temporarily and oxygen is carrying minus. Write both the products in the reactant side in third step, C6H5, CH, and this is O minus and the H plus C6H5, C double bond O, OH. This is written as a second reactant and this is written as a first reactant. Simply these two are taken in the reactant side. Now what is the change in the third step? Actually this is to be neutralized. For the purpose of neutralization of O minus, there is a need of hydrogen. That hydrogen is given by this OH group. So the hydrogen which is present in the OH of benzoic acid is available for this O minus. We can extend an arrow like this. Try to understand. Oxygen is giving electron to this hydrogen. So hydrogen can be added to this. It is called as protonation. At the end of the protonation, we can have a neutralized product C6H5CHH, and this is becoming OH. In addition to that, we can have C6H5 C double bond O minus. It is nothing but benzoate. This is the reason why we are getting the sodium benzoate as a product in the case of Cannizaro reaction. Try to understand. Already there is a presence of Na plus that might be combining with this Na plus to form sodium benzoate at the end. And this mechanism is called as Cannizaro reaction. I repeat in simple words. The step 1, benzaldehyde, where we are supplying the sodium hydroxide. OH minus is contributing electron to the carbon. The nearby bond is breaking up. Oxygen is carrying minus. Take this in the reactant side. Write the first molecule of benzaldehyde. We are shifting this hydrogen. The proton is shifted. The hydrogen minus along with the electron pair, and it is added with this carbon oxygen bond is broken and that carries minus. Similarly, to compensate the valency of carbon, there is a need of one more bond. It is possible like this, shifting of electron pair. So we are getting these two as a product. These two products are again in the reactant side. In order to neutralize this O minus, there is a need of hydrogen plus that is contributed by the benzoic acid it has got a replaceable hydrogen. After the protonation, we can have the benzyl alcohol. The compound 1 is benzyl alcohol and other will be the sodium benzoate. This particular mechanism is called as Cannizaro reaction mechanism. That's all. Good luck.